Hi, I'm Oscar. This is my video presentation for the CW2 incident analysis. In this investigation, I will act as the Tier 2 SOC analyst for the Forfrey Brewing Company. I was tasked with investigating a security incident involving their AWS cloud infrastructure. Using the Sports V3 datasets, I reconstructed the incident to identify a critical data breach involving S3 buckets and compromised user accounts. I have documented my full finding in the GitHub repository, which including the report's evidence screenshot and my methodology following the incident response framework. First, regarding the environment setups, as you can see, I deployed Spun Enterprise on an Ubuntu virtual machine. This setup eliminates a dedicated isolated SOC environment. As you can see here, the index is populated with a millions events covering critical source types like cloud tree, access logs, and Winhouse mode. This data filing allows me to correlate the source with the endpoint telemetry. Now, let me walk you through the investigation flow. Unlike a standard quiz, I approach this by following the attack lifecycle. The investigation starts by identifying the root cause. I search for the API call put buckets ACL, which is used to change the permission. Looking at the JSON output, specifically the entry field, we can see the permission was all set to all users. This confirmed the following code basket was made public. The next question is who did this? By analyzing the country identity field, I identified the user bistro as the account response for this change. Then I pivoted to investigation security posture to the user. This query is search all AWS user. Now you can see that we have the 4 users in here. This search reveals the multiple users including Bistro and all the others were logging in without the multi-factor authentication. In the production SOC, this is a critical failure that's likely facilitating the account compromise. Finally, I checked if the exposure was exploited. These results confirm the breach. An external IP successfully uploaded a file named openbucketpsfix.txt. This result confirmed the breach. An external IP address successfully uploaded a file named openbucketpsfix.txt. This proved unauthorized write access was achieved. I also tracked the GET request to check is there any outsider to download the file from the cloud. For the forensic purpose, I also checked the pistol, his house name, and the computer names. Going beyond the basic guided question, I performed the proactive threat hunting on the endpoint associated with user pistol. I hypothesized that the physical laptop may also have compromise. As you can see in this, as you can see here, the browser process on host was consumed 100% of the CPU sustained privilege. I particularly select top 6 high CPU usage process to trace the detail of the browser process to use the high CPU usage is focused on after 9:30 p.m. correlated with DNS traffic to mining pool. This is stronger in delicate crypto-tracking infection. This suggests the attacker privilege from the cloud environment to the physical endpoint. Then I check the DNS traffic to see is there have any mining activity related and match with the CPU using time. Those domains related for the mining. To conclude, this investigation confirmed that a list of multi-factor authentication and proper S3 configuration leads to a verified data breach. My recommendation is immediately enable public access on all AWS S3 buckets, enforce the multi-factor authentication for all users immediately, implement the spam alerts for the high-risk API call 9 put buckets ACL so the SOC tier 1 can respond in the real time rather than the after the incident. Thank you for watching.